Okay, we're going to continue on with C and D, also from example 6. So we'll go ahead and we'll take a look at the instructions here real quick. So simplify, use positive rational fractions or integers, that means exponents if necessary. Do not use negative exponents or radical notation. We don't want to see any roots in our final answer here. So to take care of this one, we need to go ahead and make sure to apply these, and remember that that's 9 to the first and 27 to the first. We're going to only multiply these exponents together. So that's 9 to the 3 over 2, and then s to the first and t to the first. So that'll be s to the 3 over 2 and t to the 3 over 2, all over the denominator, which is 27 to the 2/3. S to the third times 2, so 3 times 2/3 is just 2. And then we've got a t to the negative 8/3. All right. So if we take a look at this top part here, this is 3 squared. And 3 squared to the 3/2 power, well, that's 2 times 3 over 2, which is just 3 to the 3rd power. We'll clean this up here in just a little bit. S to the 3 over 2 is kind of the way it is right now. T to the 3 over 2 is the same way. If we look at the bottom, this is 3 to the 3rd power times 2/3 is 3 squared. S squared is okay as well. And then we have a t to the negative 8 over 3, and we could actually go ahead and move that to the top here and make that t to the 8/3. 3 to the 3rd over 3 squared is just 3 in the numerator position. So we want to take care of the s's now. We've got s to the 3 over 2 and s squared. So if we do that over here on the left, or the right hand side, this 3 over 2 minus 2. 2 is 4 over 2. So we have an s to the negative 1/2 in the top. If we take that and move it to the bottom, we're going to have an s to the 1/2 left in the bottom. There's 2 is bigger than 3 over 2, so you're definitely going to have some positive exponent left down here in the denominator. T to the 3 over 2 and the 8 over 3, we're going to have to add 3 over 2 and 8 over 3. Well, 3 over 2 can be rewritten as, let's see here, we're going to have to multiply this by 3, so that's 6, and that's 9. And then we're going to have to multiply this one by 2 over 2, so that would be 16 over 6. So that's 25 over 6. And that's going to be the exponent for the t. 3 over 2 plus 8 over 3, we found out, was 25 over 6. If we take a look back, we took care of the 3's, we took care of the s's, and we took care of the t's, and that's all we really have to do, so we can go ahead and just box that off as our final answer. To take a look at this one here on the right, and I'll try to use maybe a different colored writing utensil for this one, we're going to do kind of the same thing, but what I'm seeing right now is I'm seeing that we have a fraction inside parentheses all being raised to some exponent. So it might be nice at this point to go ahead and clean this up on the inside. And clean it up, here's what I mean. Take all these negative exponents, make them positive. So in this next step, here's our fraction bar. Everything's inside. And we've got, still have a negative 3 over 4. We're just working inside the parentheses here. A to the 3 over 2 will stay there. This a to the negative 7 over 2 though, is going to come up to the top. And the exponent then will be positive. B to the negative 5 over 3. If we move that to the other side of the fraction, that's b to the 5 over 3. And we've got b to the 2/3 down there as well. You'll notice now that we have like bases. We're multiplying like bases, so we can add these exponents and add these exponents. So in the numerator, we've got 3 over 2 plus 7 over 2, which is 10 over 2, or just 5. And then in the denominator, this is all being raised to the negative 3 over 4 power. Then in the denominator, we've got 5 over 3 plus 2 over 3, which is 7 over 3. This is a negative exponent, so one trick that you can use that's mathematically accurate, I guess it's really not a trick, it is algebraically okay to take the denominator and numerator and use the reciprocal. So we will go ahead and flip this fraction on the inside, and then that negative sign will go away. It's just positive 3 over 4. Next, we're going to use our power of power rule to multiply the 7 over 3 and the 3 over 4. These 3's will cancel, so we'll just be left with 7 over 4. And 5 times 3 is 15 over 4. So this will be a to the 15 over 4. Remember, our instructions stated specifically to not use any kind of radicals in our answer, or any negative exponents as well. So hopefully that wasn't too far off the page there. You can see now the flow through. So let's just do an instant recap. If possible, clean up everything on the inside. We just moved our bases and negative exponents. Then we just used our multiplying like bases rule, went ahead and added the exponents. You can flip the fraction or take the reciprocal of the fraction, and then this sign will change. And then just go ahead and multiply all the each one of these exponents by the exponent on the outside, and you've got your final answer.